Alright, today we're going to be learning about area between two curves, which is 7.1 in the textbook. So, let me clear the area. So, area between two curves is quite simple. All we got to do is use what we already know. So, let's draw really quickly. Curve like this, and a curve like this. Okay, so area between two curves would be this region right here. And how we find this is the equation A equals the integral from A to B, and here would be A, here would be B, the area from A to B of f of x minus g of x, where f of x is this top function of the region, and g of x would be the bottom function of the region that we're looking at. And then, of course, dx. So the only place that this could get tricky, well, it's really hard to make this tricky, but it's hard when maybe a curve does something like this, and sometimes the curve is on top, f of x is on top, and sometimes f of x is on the bottom, so you have to split this up into two integrals. And it also gets tricky when you don't know what limits of integration that you're looking for. So what you have to do is you have to set fx equal to g of x and solve for x. Alright, so let's do some examples. Pretty straightforward so far. Okay, let's jump right into a sort of tough one. Let's see, number 5 from 7.1. And the picture of the graph. It's always helpful to draw a graph on these. So here's a graph. And we're finding the region or the area between y1, which is 3 times x cubed minus x, and then the x-axis. So what we have to do is we have to find limits of integration, which are this, and this, and then split this up into two integrals because, as you can see, f of x is going to be on top of the x-axis right here, but below the x-axis here. So, so this is 0. Yeah, my picture's pretty bad. And then we know that, well, by factoring y of 1, we take 3x, and now it's x squared minus 1, which equals 3x times x plus 1 times x minus 1. So that means zeros would be at 0, 1, negative 1. So now we have everything we need, and the area is going to be the integral from negative 1 to 0 of the top function, which is 3x cubed minus 3x, and then minus 0 because that's the x-axis, and then plus the integral from 0 to 1 of 0 minus our function, which is going to be negative 3x cubed plus 3x. Alright, now we just have to solve it. So it's going to be 3x to the 4th over 4 minus 3x squared over 2, negative 1 to 0, plus negative 3x to the 4th over 4 plus 3x squared over 2 0. And if we plug all this in, what we get, let's see, let me put the others into the calculator. Alright, so 3/4 minus 3/2 plus negative 3/4 plus 3/2. Oh, whoops. Wait, what? Oh, yeah, whoops. We had to remember to subtract, so whoops. 3/4 negative 3/4 plus 3/2. Okay, so the answer should be 3/2. But let me just wait. That doesn't make sense, does it? Let me check real quick. No. That's menu. Oh yeah. Okay, cool. It is 3/2. Doubted myself. All right, and now let's do one more example. If you guys aren't feeling so confident, this one should help out. Number 6. Number 6 is in the area between two curves. One is x minus 1, and the other is x minus 1 to the third. So that'll be like this. So we're looking for the area here and the area here. So our two curves will intersect. We have to figure that out. So x minus 1 squared equals 0. And x equals 1. That's the x-intercept of both of them. So that's one intercept, and then let's see. Oh man. Wait, x minus 1. This is a hassle. Wait, that's x squared plus 2x. X squared minus 2x plus 1 minus 1. So x squared plus 2x equals 0. Which means oh yeah. So that means they intercept at x equals 0, x equals 1, and x equals 2. Yeah. All right, so after all this work, we find that they intersect at 0, and then plug in back in 0. 0, negative 1, 1, comma, 0, and 2, comma, 1. So knowing this, we can set up our integrals. So let's do it. Let's clear this out. So area will equal the integral, and for the first segment, which is 0, all right, 1 sec, 0 to 1, the top one will be x minus 1 cubed minus x minus 1 dx plus the integral from 1 to 2 of x minus 1 minus x minus 1 cubed dx. And if you plug this into your calculator, which I'm going to do because that's a lot of integration that you already know how to do, I'm sure, you should get 1/2. All right, there we go.